Hello, everyone. I want to apologize for taking so long in grading quiz 7. The quiz is graded in Blackboard, so take a look at that. Yeah, I want to go over this quiz. People did well. The median was about a solid B, and the average was a little lower, solid C. So, all right, so we have a 5-year loan. I-12 is 9%, to be paid off with monthly payments beginning 1 month after the loan is made. Okay, so I have monthly payments here. Each payment, coming after the other is 1%. So it starts at 1,500, then it's 1,500 times 1.01, 1,500, 1.02, sorry, 1,500, 1.01 squared, et cetera, et cetera. Find OB36. So this is really just like the homework problem. So first of all, if J is the effective monthly interest rate, then we're given I-12 is 9%. So you divide I-12 by 12 to get the effective 1/12 yearly interest, which is monthly interest. So 0.09 over 12, 0.0075. All right. Right, so we start off with K1 is 1,500, the first payment. K2 is 1,500, 1.01. And so the general formula is just 1,500, 1.01 T minus 1. Okay. All right, so let's use the prospective method, probably the simplest way to do this. So some people did actually find the original loan amount, the present value, which is not too hard. And then they used the general formula that the outstanding balance is just the future value of the loan amount after 36 payments minus the future value of payments after the 36th payment. That's a little messier, but that absolutely is correct to do. It's just a little quicker to do the prospective method. So here we have n is 60. It's 5 times 12. It's a 5-year loan. Payments are each month, so 60 months. So the formula is it's K37 times nu. I should say nu is 1 over 1.0075. And just keep going until we hit K60. And then it's nu times 60 minus 36, which is 24. Okay, right, so this is going to be, pull out the 1,500. Well, K37 is 1,500. 1.01 to the 36 over 1.0075. So again, I'm bringing out the 1,500. And everything just increases by a power of 1. All the way until we get to 1.01 to the 60th. 59, not 60. 1.01 to the t minus 1, t is 60. It's 59. That's right, it should be squared here. And this is going to go to 24. 60 minus 36. Okay, so just factor out your first term here. Give myself plenty of room. This is going to be 1 plus 1.01 over 1.0075. I have it squared. The next one, squeeze this in, but should be no problem. 1.01 over 1.0075 to the power, this here, 59 minus 36 gives you 23. 24 minus 1 is 23, so the power is 23. Right, so this is going to be just plug and chug into the finite geometric series formula. One minus this here, 1.01, 1.0075, 24 over 1 minus this here. I'll do this in a calculator in a second. Okay, so let's get the calculator out. Thought I had it out, but don't know what happened to it. But okay, so here it is. Okay, so the easiest thing to do is to use your storage keys. So let's get 1.01 over 1.0075. In the one spot, probably the easiest thing to do. Okay, so yeah, raise this to the 24th, negative plus 1, divided by 1 minus, recall 1, times 1500 times parentheses 1.01 over 1.0075. Yeah, actually, I think I screwed that up a bit. I thought it was this whole thing at 36, so let me just start that over quick. Right, so still save this, so it'll be a little quicker here. So yeah, that's the 24th minus plus 1 over 1 minus 1 times 1500 times 1.01 to the 36 over 1.0075. Now we get the correct answer. So the calculator really isn't that bad. I just personally love having a multi-view. That's just my personal preference. Yeah, it's really not the worst. I don't know why it won't let me keep it up, but whatever, 6.10 and 2 cents. Okay, so for the next one, you have a 30-year loan. Effective annual interest, not nominal interest, effective annual interest is 9% for the first 10 years and 7% for the next 20 years. We have constant yearly payments of K. So people did monthly, some people did monthly, and not monthly payments rather. It's yearly payments. Payments are yearly, not monthly. They're at the end of each year. Their payments beginning 1 year after the loan is made. Find K, OB10, and OB25, and fill in this amortization table, which is going to be a pain if this doesn't let me keep this up, but anyway. All right, so where to begin? Well, let's just draw a time diagram. No harm in that, doesn't take too long. So we go up to 10. Whatever. All right, so don't have much room here, but here, this is 9%, whereas here, from 10 onward, it's 7%. Okay, so yeah, we don't know what the payments are. It's just constant. Payments start at the end. Sorry, payments start 1 year after the loan is made. So we have 30 of them. Sorry, this should be 29 and 30. That. Okay, but yeah, all we're doing really is just using, so remember the present value of the loan, which is the loan amount, is simply the present value of the loan. It's the present value of these payments. Okay, so what do? Break this up into two, as usual. Start from here. This is just simply 10A, 10. Oh, sorry, I don't know where, K times A10. 10 years, but anyway. And interest is 9%, so it's 0.09. And so this is just going to be 6.41766 times K. So for the other one, it's 7%. So 20 years. A 20.07, and we have to discount this. So some people didn't discount this. You really can't forget your basic annuity logic. That's really the heart of this course, and really the heart of passing exam FM is your basic annuity just logic. 20.07 times 1.09 to minus 10, because we have to discount this by 10 years under 9% interest. And this becomes, I don't know why I put a 20 here, it's just a K. Sorry about that, that's very strange. Put that there, but glad I caught it. So this is going to be 4.47503. So the loan amount is 100,000, which is equal to the present value. So it's going to be 6.41766 plus the 4.47 for 4.47503. So you get K is 9180.47067. 47067. Okay. Yeah, so we can fill out this amortization table now. Let's just do 471, I guess. Okay, so interest is just, well, 100,000 times 0.09 is 9,000. So you subtract, have 180. Let's just do up to nearest cent. So someone complained that there's not a lot of room here. Well, didn't really intend for you to do your arithmetic here, but anyway. Okay, so this is the principal we paid. So you take 100,000 minus 180.47. You get 999,819.53. Take this outstanding balance times 0.09, you get 89.8376. Take 9180.47 minus 89.8376. You have 196.71 left over to chip away at your principal. Take the 99.819.53, subtract 196.71, chip off that much from your previous outstanding balance, and you have, so you can see under an interest rate like this, you really slowly chip away at your outstanding balance. I mean, really slowly, unfortunately, even though your payments are pretty damn big, almost 10,000 a month, oh, sorry, 10,000 a year. All right, last but not least, take 99,622.82 times 0.09. You get 8966. And 5 cents. So yeah, your interest payments are almost as much starting off as your total payments. Just, barely enough to chip away at your principal. So 9180.47 minus 8966.05 gives you 214.42, and 9962.82 minus the 214.42, 99408 and 40 cents. So that's the table. All right, not a lot of room here. So let's get rid of some, there's some stuff here. A bit cumbersome, but all right, well, that works. Plenty of room. Okay, so I think the easiest thing to do is really use that generic formula that always works. When you have situations where you have differing interest rates, differing payments, you're not sure, exactly what works. Well, this always works. The prospective and retrospective methods always work too. So you kind of have these three formulas that always work. And what I like about this formula, it's really not that cumbersome to use. So you just take the future value after 10 years of 100,000, 100,000, 1.09, minus payments, or minus rather the future value of your payments after 10 years. What is it? 47067. So it's S10.09, and this becomes 97258, 12179. Now you can do the loan reset. Basically same logic here. Starting at t equals 10. This is kind of your loan amount. So you figure out how much the loan amount is, future value of the loan amount after, well, 15 years now. And now here interest is 7%. And you figure out how much the accumulated value, the future value, same thing, of your loan payments are. Again, under 7% interest. Because after the 10th year, interest is 7%. Before the 10th year, interest is 9%. So yeah, future value of your loan amount minus future value of your payments, 15 years, because this is 10 years into the loan, you get 37, 641 and 98 cents. So definitely the 7% really helps a lot, chipping away at your loan versus the 9%. Where, you know, here after 10 years, you only paid off less than $3,000 on your whole loan. So, yeah, I mean, you know, 9% is an egregious loan rate, and avoid it at all costs if you can. You learn nothing other than, if you learn nothing in this course other than, you know, this problem telling you how awful 9% is, well, and definitely a few people didn't really understand the amortization table. That's really important, not even for this course, but just for accounting and finance to understand. Particularly if you're an accounting major, you have to understand amortization tables. It's just very important for accounting purposes. I think I did an accounting example actually in one of the videos. All right, anyway, so yeah, these are your answers. All right, well, I'll get 8 graded in the next few days, by Wednesday, certainly. And I'll have a video up for quiz 8 by Wednesday. All right, so long, take care, bye-bye.